Let's run through a complete walkthrough of the solutions to free response question number 4 from the 2025 AP Calculus AB exam. Let's dive in. So throughout this problem, we're working with the graph of this function f that we're using to construct a new function g. So g is defined to be the integral of this function f from the limit 6 up to the limit x, where x is the variable, the input of the function g. Now, when I see a function defined like this on the AP exam, I immediately think Fundamental Theorem of Calculus. This definite integral where there's a variable as a limit screams Fundamental Theorem of Calculus. So we're going to use that at least once, probably multiple times throughout this free response question. So for part A, we are asked to calculate g prime of 8, and we have to show our setup, okay? So what I would just say immediately is we're going to use the Fundamental Theorem of Calculus. Because what does the Fundamental Theorem say? It says that if I take a function and I integrate it, so here we're integrating the function f in some sense to get the function g. If I want to undo that process, all I have to do is differentiate. So here we want to know what g prime of a value is. So we need to know what g prime of x is. Well, that is the derivative of g. So when I take the derivative of g, what I get back is that f, that integrand that I started with. So that tells me that g prime of 8 is just going to be f of 8, which conveniently I can read off from the graph, right? F of 8 is just 1. So that is my final answer. Pretty straightforward. So how are the points divvied up here? Well, we certainly get 1 point for our final answer, but we also get 1 point for our setup, okay? Applying the Fundamental Theorem of Calculus somehow to relate g prime back to f. And that's all there is to it. Good work. We're going to have to work a little bit harder in part B, but it's still going to be totally fine, I promise. So in part B, we're asked to find all the x values at which this new function g has an inflection point. And I just want to remind us from part A, we did figure out that g prime of x is equal to f of x via the Fundamental Theorem of Calculus. So here, I need to remember what it means to have an inflection point. So an inflection point occurs where concavity of g changes. And now there's a couple of different ways that we can detect concavity, either involving the first or second derivative of the function g. Here, because we have this nice equation relating g prime to f, and we have the graph of f, I think it makes sense to work with the first derivative g prime. So that means for the concavity to change, that g prime must change from either increasing to decreasing, or vice versa, okay, or decreasing to increasing. So that's great because remember g prime is just equal to f. And I can very easily see on the graph of f where it is increasing and decreasing. So let's mark that up. So we start off decreasing and then we are increasing. So I'll change to a different color. And then we're decreasing again. And then f is increasing again. So whenever that increasing, decreasing behavior of f changes, we are going to have an inflection point of g. So I have 1 point, 2 point, and another point. So the x values that I care about are -3, 3, and 6. Okay, so that's going to be our answer here. So x equals -3, 3, and 6, because f, which is equal to g prime, changes from increasing to decreasing or decreasing to increasing. It's a bit of a mouthful to get out. There are other ways that you can justify this answer, but I think this is the most surefire, the least likely you're going to mess it up. It's worth sticking to this, I think. So, how are the points divvied up here? Well, we get 1 point for our correct answer, those 3x values, and then I get 1 point for my reason, my justification. However, I am convincing the scorer that I've found all the x values of those inflection points. Well done. Okay, part C wants us to directly work with the definition of g to calculate some values, namely g of 12 and g of 0. So let's figure out what's going on here. Let's do g of 12 first of all. So remember, our definition of g is that it is the definite integral starting at the lower limit of 6. So I'm always starting here at x equals 6, and I'm calculating an integral. So when x is 12, I'm going to move all the way over here. I'm going to calculate the area under the curve of f between x equals 6 and x equals 12. So in particular, that is this really nice right triangle. So the area under the curve is the area of that triangle. That is really straightforward. So it's going to be 1/2 times the base, which is 6, times the height, which is 3. And so my value of g of 12 is just 9. Let's look at g of 0 now. So g of 0, whoops, we have to finesse a little bit because g of 0 takes my x and replaces it with 0. And for that integral, there's something not quite standard. Namely, my lower limit is larger than my upper limit. So for us to interpret the definite integral as the area under the graph correctly, our limits need to be in the correct order. So in particular, I want to rewrite this as an integral from 0 up to 6 of f of x. But remember, our property of definite integrals says when we do that swap, we negate the value of the integral. Okay. So I now am looking at the area under the curve of f from 0 up to 6 with that negative sign. But notice now what I'm getting is a semicircle. That's nice. I know the area of a semicircle is half the area of a circle, and I know the area of a circle. So I'm going to get negative half the area of pi r squared, and the radius of the circle, if we count boxes, is 3. So this is going to be negative 9 pi by 2. Okay. That's us done. How are the points shared out here? Well, I get 1 point for each answer. Pretty straightforward stuff. Nice. So part D, the final part, is probably where we're going to put in most of the work. Let's see what it's asking for us. So we want to figure out where on this interval from negative 6 up to 12, g takes its smallest value. So where does g attain an absolute minimum? Well, where my mind immediately goes here is I'm being asked for an absolute minimum on a closed interval. So what I'm going to do here is, especially because they want us to justify our answer, is use the closed interval method, or the candidate's test, you might call it. So the plan there is to set up a table of values where I'm going to figure out the value of g at some values, namely, okay, the endpoints. We always check the endpoints, negative 6 and 12. But then I also need to figure out some special points, some special x values in between that I should check. Namely, where g might have a local minimum or maximum, in this case, minimum. Okay, so we're looking for turning points of the function g, namely critical points. So we need to solve g prime of x equals 0 to find those potential turning points that might give me the true absolute minimum of this function g. Well, the great news is we know what g prime is. Fundamental Theorem of Calculus. We use this in part A and part B. G prime is just f. So we want to solve f of x is equal to 0. Well, I can read this just from the graph, right? So I certainly know that x equals -6 and x equals 12 are in the table. What other values do I need to put in? Well, wherever f is giving me 0 as its output, so where f is crossing the x-axis. So this happens at x equals 0 and x equals 6. So those are my two additional x values that I need to consider in the table. Now it's a simple case of evaluating g at these 4 inputs, figuring out which one of those values is smallest and pointing at it and saying, that's the minimum. Okay, that's where the minimum occurs. So let's have a look here. Well, the good news is I figured out some of these values already, right? We figured out that g of 0 was negative 9 pi by 2 in part C. Okay. If you don't remember that, well, remember it was really asking us about the area of that semicircle. When I substitute in x equals 0, we get that negative because our limits are in the wrong order. We also figured out what g of 12 was, right? The other endpoint. So that was the area of this semicircle. Sorry, not semicircle, triangle. So half base times height there, as we saw in part C, gives us 9 as our answer there. Now I have these two other ones to figure out. Well, let's just take them in turn. The integral from 6 up to -6, we'll notice that starting at 6, I get this area above the x-axis and that area below the x-axis. They're both semicircles of radius 3. So the fact that I have an equal area above the x-axis and an equal area below the x-axis means they will cancel out and give us 0 as that g value. Notice again we've got the limits in the wrong order, 6 up to -6, but because the integral is 0 either way, -0 still just gives us 0. So now we need to look at the answer here for our final input, namely x equals 6. Well, that's really straightforward. I left the easiest one for last because when you take the definite integral, you start at 6 and you integrate, you don't go anywhere, you don't get any area at all. The area is 0. Okay, we haven't actually done anything for our definite integral. So here we have 0 as our input, our output there. Okay. So now we get our pointing finger out and we point at the smallest value that we see. Aha! It's the only one that is negative. That is the smallest. So what we can say is g attains an absolute minimum at x equals 0. We're not asked for the actual absolute minimum value here, just the x value that produces it. So we're done. Have we justified? Well, yes, this table of values, this use of the closed interval method is a sufficient justification. There are other ways you can justify, maybe using the first derivative test, the second derivative test. Those can get a little messy. Table of values, really straightforward, really nice, very concrete. It's what I would recommend doing in this sort of problem. So how are our points divvied up? Well, we get 1 point for considering that we need to look at g prime of x being 0. Okay, knowing that the table of values needs to have the endpoints, but also those x values are those critical points as well. We get 1 point for our answer, certainly, x equals 0, but then we also get 1 point for our justification step, which for us was this table of values. And we're done. So there you have it, another free response question from the 2025 exam in the books. If you're doing these in order, you're now 2/3 done with the free response questions. That is awesome. How did you get on with this one? Let me know in a comment. Part D, let me know if that was where you worked the hardest. I suspect it might have been. But if you have any questions about any of these parts, please just drop a comment and I will for sure leave a response. Apart from that, I'll put a link to the other free response questions in this exam. I've got a playlist of those. And if you want to practice some multiple choice questions, I'll also put a link to that playlist as well. Apart from that, I'll look forward to seeing you in my next video. Bye.